Hello everyone, welcome to another video on our channel. Today we are going to talk about one of the most fascinating moons in the solar system, Titan, Saturn's largest satellite. But why is Titan so important for science and for future missions like NASA's DragonFly drone? Let's dive into this distant world and find out. Titan stands out in our solar system for several impressive reasons. With a diameter of about 5,150 kilometers, Titan is larger than the planet Mercury and is the second largest moon in the solar system, only surpassed by Jupiter's Ganymede. What really makes Titan unique, however, is its dense atmosphere, composed mainly of nitrogen with traces of methane and other hydrocarbons. This atmosphere is so thick that it multiplies the pressure of Earth by about 1.5 times on the surface of Titan. One of the most intriguing aspects of Titan is its similarity to early Earth. It is believed that the atmospheric conditions on Titan resemble those of Earth billions of years ago, before life began to alter our atmosphere. This makes Titan a natural laboratory for studying the chemistry that could lead to the emergence of life. Besides its atmosphere, Titan has a rich and complex surface, with mountains, rivers, and lakes. However, unlike Earth, Titan's lakes and rivers are not made of water, but of liquid methane and ethane. These conditions create an alien hydrological cycle, where liquid methane evaporates, forms clouds, and falls as rain, sculpting the surface in ways that resemble the erosive features found on Earth. Exploring Titan is not just a journey to understand another world. It's also a way to look back at Earth's past and forward to the future of space exploration. By studying Titan, we can gain insights into atmospheric and geological processes that might occur on other worlds, potentially habitable or not. Understanding Titan also helps us prepare for future interplanetary missions. Titan's thick atmosphere and reduced gravity offer a unique environment not only for studying chemical and geological processes, but also for testing technologies that could be used on other worlds. NASA is particularly interested in how flight systems, like those of the DragonFly, can operate in conditions so different from those on Earth. I hope this glimpse of Titan has piqued your curiosity about what makes this satellite such a fascinating object for space exploration. After an exciting introduction to Titan, it's time to meet the DragonFly, NASA's innovative drone designed to explore this intriguing world. DragonFly is not just a drone. It's a true technological marvel, crafted to face the unique challenges that Titan presents. Let's find out how this drone can change the way we explore other planets and moons. The DragonFly is a rotorcraft drone, which means it has multiple rotors, 8 to be exact. These rotors enable it to fly in Titan's dense atmosphere, which, although thicker than Earth's, has only about 14% of Earth's gravity. This creates ideal conditions for flight, as the dense atmosphere provides more lift, while the low gravity demands less effort to take off from the ground. This revolutionary drone is comparable in size to a small car, but every aspect of its design has been meticulously planned to maximize its efficiency and scientific capability. DragonFly is equipped with various scientific instruments designed to study the complex chemistry of Titan. It will analyze soil samples, measure the composition of the atmosphere, and even study the satellite's meteorology. The goal is to learn more about the building blocks of life and how they might form in extraterrestrial environments. One of the most notable features of the DragonFly is its ability to fly to multiple locations during the mission, something that previous vehicles, like rovers and landers, could not do due to their mobility limitations. With the ability to traverse dozens of kilometers, DragonFly will offer an unprecedented view of Titan's geological and chemical diversity. This allows for much more comprehensive exploration than would otherwise be possible. To ensure everything operates perfectly, the DragonFly is powered by a radioisotope thermoelectric generator, which uses the decaying heat from a radioactive isotope to generate electricity. This system not only provides reliable, long-lasting power, but also helps to keep the drone's instruments warm in an environment that can reach temperatures as low as -180 degrees Celsius. Besides its scientific function, DragonFly is also a significant milestone for aerospace engineering. It will face challenges such as long-distance communication with Earth and autonomous navigation in an unknown environment. By learning to operate the DragonFly on Titan, we can develop technologies for future missions to other worlds with atmospheres. I hope you now have a good idea of how the DragonFly will transform the exploration of Titan. Now, let's delve into the scientific objectives of this exciting mission and what researchers hope to discover about Titan and, possibly, the origins of life on other worlds. The primary goal of the DragonFly mission is to understand the habitability of Titan and explore its prebiotic environment, environments that, on Earth, would have enabled the origin of life. DragonFly's unique ability to perform multiple flights and landings will allow scientists to study various habitats on Titan, from its vast dunes to the plains rich in organic compounds and the regions where surface liquids and ice may interact. One of the main focuses of DragonFly will be the detection and analysis of complex organic molecules. These molecules are the building blocks of life as we know it, and Titan is replete with them, both in the atmosphere and on the surface. DragonFly is equipped with a mass spectrometer and other instruments capable of conducting detailed chemical analyses. Studying these compounds may give us clues about how life could arise under extraterrestrial conditions. Titan has an active and complex atmosphere, with a methane cycle that resembles Earth's water cycle, featuring precipitation, rivers, and seas. DragonFly will study this cycle closely, including measuring wind patterns and analyzing the chemical composition of the atmosphere. Additionally, its geological instruments will help understand the structure and composition of the surfaces it lands on, providing insights into the geological processes of Titan. Another intriguing goal is to explore the possibility that liquid hydrocarbons on Titan, primarily methane and ethane, might harbor life forms or chemical precursors to life. DragonFly will investigate the interactions between the organic-rich surface and these liquids, potentially revealing chemical processes similar to those that might have occurred on early Earth. Finally, the data that DragonFly collects will help to feed astrobiological and cosmochemical models, expanding our understanding of how planets and moons chemically evolve. Insights from Titan could be applied to better understand other celestial bodies in the solar system and beyond, particularly those with thick, organic-rich atmospheres. These explorations will not only advance our scientific knowledge, but also test new technologies that could be crucial for future missions in extreme environments. One of the biggest challenges of sending a mission to Titan is the immense distance between Earth and Saturn, which ranges between 1.2 billion and 1.7 billion kilometers. This results in a significant delay in communication. It takes 67 to 84 minutes for a signal to travel in just one direction. To handle these challenges, the DragonFly is designed to have substantial autonomy. It can make navigation and scientific decisions on-site without waiting for instructions from Earth, using advanced artificial intelligence algorithms and a robust set of sensors to navigate Titan's varied terrain. The conditions on Titan's surface are hostile, with temperatures dropping to about -180 degrees Celsius and an atmosphere composed mainly of nitrogen, as well as methane and ethane in gas and liquid forms. To operate in this environment, the DragonFly is equipped with an innovative thermal insulation system and a radioisotope thermoelectric generator, RTG. This system not only provides constant power, but also keeps the instruments and electronic systems heated. Flying in Titan's thick atmosphere, which is 4 times denser than Earth's, presents both challenges and opportunities. NASA engineers designed the DragonFly with specially adapted rotors that can take advantage of the dense atmosphere to perform longer and more efficient flights than would be possible on Earth. This flight capability greatly expands the potential exploration area compared to previous missions that relied on rovers or static landers. The mission is designed to last at least 2.7 Earth years, but has the potential to extend even further, depending on system performance and initial findings. This requires that all components of the DragonFly be extremely durable and capable of operating under the continuous stress of low temperatures and radiation. Before launch, the DragonFly undergoes a series of rigorous tests on Earth, which simulate the conditions of Titan as closely as possible. These tests are vital to ensure that each system functions as expected, since on-site repairs are impossible. This set of solutions highlights NASA's ingenuity and innovation in facing the challenges of exploring a world as distant and different as Titan. With each problem, the mission team responds creatively, designing technologies that not only meet the needs of the mission, but also pave the way for future space explorations. One of the main goals of DragonFly is to investigate the prebiotic chemistry on Titan, which may offer new insights into how life could have arisen on Earth. Detailed analyses of organic compounds on Titan could reveal chemical processes similar to those that occurred on Earth before life emerged. This knowledge could not only fill gaps in our understanding of the origin of life, but also inform the search for life on other worlds. Titan is unique in the solar system for its seas and lakes of liquid hydrocarbons. DragonFly will explore these areas to study their chemical and physical interactions, providing insights into geological and atmospheric cycles that significantly differ from those on Earth. These studies will help scientists understand how planets and moons with hydrocarbon-rich atmospheres could support life forms or complex chemical processes. The mission also has significant implications for astrobiology, as it will provide crucial data on the habitability of environments that drastically differ from Earth. By understanding the conditions on Titan, scientists will be able to refine theories about what types of worlds beyond our own might be capable of supporting life. This information will be vital for future missions seeking life on exoplanets and other moons in the solar system. Beyond its scientific impact, DragonFly is also paving the way for the use of drones and other autonomous technologies in space missions. DragonFly's ability to navigate and make independent scientific choices in an extraterrestrial environment is setting a new standard for what is possible in terms of space exploration. The successes and lessons of this mission will directly influence the design and implementation of future missions to other distant destinations. Finally, DragonFly will significantly contribute to our understanding of planetary science and cosmochemistry, offering new data on the composition and dynamics of one of the most enigmatic bodies in the solar system. These discoveries will be applied to better understand other similar environments in the universe, expanding our knowledge of the cosmos. The DragonFly mission is scheduled to launch in 2026. Before the launch, a series of rigorous tests and design reviews are conducted to ensure that all drone systems are optimized for the extreme conditions of Titan. The drone will be launched aboard a powerful rocket capable of escaping Earth's gravity and setting it on the right course for Saturn. After the launch, DragonFly will embark on an interplanetary journey that will last approximately 8 years. During this time, it will travel through the solar system using gravitational assists from other planets, such as Mars, to gain speed and adjust its trajectory towards Saturn. This journey is not only long but also critical, with several course corrections and system checks being conducted to ensure that DragonFly arrives at its destination as planned. The arrival at Titan is scheduled for 2034. This phase is one of the most critical and challenging of the mission. DragonFly will use a combination of parachutes and its own rotors to decelerate during descent through Titan's dense atmosphere and land smoothly on the surface. This landing approach is meticulously planned to handle Titan's atmospheric and topographical variations. Once on Titan, DragonFly will begin its primary mission, which will last several Earth years, each planned to last at least 2.7 Earth years. During this time, the drone will explore its initial landing area and subsequently fly to new sites of interest. Each site will offer unique opportunities to collect data on Titan's geology, meteorology, and chemistry. Flights are planned to be executed in stages, with each new flight taking the drone further from the original landing position. If DragonFly operates beyond its primary mission, it will continue to explore new areas of Titan, collecting valuable data. Meanwhile, scientists on Earth will analyze the received data, using it to deepen our understanding of Titan and to plan future missions to other worlds. This analysis phase is crucial, as insights derived from DragonFly's data could directly influence planetary science and astrobiology for many years. Finally, the DragonFly mission is a valuable contributor to the global scientific community and to humanity as a whole. The data collected on Titan will help fill gaps in our understanding of planetary systems and may have implications in fields as diverse as climatology, astrobiology, and organic chemistry. As we expand our knowledge about Titan, we also expand our understanding of the cosmos and our place within it. Thank you for staying until the end. Follow, like, and leave your opinion in the comments. See you in the next video.